Okay, welcome back again. We'll start that session and we'll cover the tab changing transformer. Okay, so now here this diagram belongs to tab changing transformer only. There are two diagrams. I will show you both the diagrams. First, let us see this one, tab changing transformer. Basically, tab changing transformer will be, it uses the, means it will be connected in the or used in the step down transformer. It will be used in the step down transformer, and tab changer will be connected, it will be connected in the high voltage winding, high voltage winding, high voltage winding, because high voltage winding always carry less current, hence easily current current can be interrupted momentarily without without spark without spark. And another reason is why we connect to the high voltage, because high voltage winding is the upper winding which can be easily tapped, which can be easily tapped. Of this tap changing transformer is, the use of tap changing transformer is to maintain the secondary voltage constant, or to maintain good voltage regulation at the secondary of the transformer, by changing the winding connection in the primary, this is what the tap changing transformer which does. Okay, now this device is called tap changer. Which will be having knobs, and these knobs will be connected to the this winding connection. So this is the primary winding or high voltage winding is available. From this, tapping is taken out. So tappings they have taken outside, and this outside tapping is connected to this tap changer with the help of some switch. Now this solid line or arrow mark shows the, now this knob is connected to this particular winding. So this much winding is connected in the circuit. Now if this knob, if it is connected here, for example, I will show it to you another color. If it shows connect here, the entire winding is connected in the transformer. If you connect the knob in this, that time what happens? Only this much winding will be connected in the circuit. That is how you are decreasing or increasing the number of turns in the primary. As you are changing the number of turns in the primary, proportionally the voltage will change in the secondary, and we are going to maintain the constant voltage at secondary level, because loads are not in our hand. Loads may get changed at any point of time. It may increase or it may decrease at any point of time. So whenever it decreases, the voltage here available at the secondary side increases. Whenever the load decreases or whenever the load increases, the voltage at this side may decreases. But what is required here? Constant voltage is required. Then how to maintain this constant voltage? By connecting the tap changer at the primary or high voltage at this particular transformer, we can maintain the constant voltage. How? You can see with the help of this transformation ratio example. As we know, transformation ratio equation. What is the transformation ratio? Transformation ratio is E2 to V2 by V1 is equal to N2 by N1. When there is a no losses and all those things, these are both are same. When this is losses are there, this cannot become equal to same. Some voltage difference will be there. Now if you consider this secondary voltage V2 is equal to N2 divided by N1 into V1. So with the help of this equation, now what we are thinking, what we are doing here, secondary voltage, that is this one V2, this is primary voltage V1, this is number of turns N1, this is number of turns N2, this number of turns N1 we are going to change it to maintain this V2 constant. For example, there are loads will be connected in parallel of the secondary of the transformer. N number of loads will be connected. So as the load go on increases on, so that some current will flow and internal some winding resistance will be there, so voltage drop increases, so the V2 whatever you are getting, it get reduces. So if this another on, then again some current is flowing, again drop increases, voltage decreases here, again one more if it is on, so one more current. In this way, load if load increases, okay, these loads are increases, then what happens? The secondary voltage V2 decreases. But what is required? We have to maintain constant voltage, V2. So for that, what is required now? This number of turns in the primary winding should be decreases. So for example, V2 is decreased. Now what I have to do? I have to increase V2 value and we have to maintain constant. To increase this V2, what I have to do here? N1 should be decreases because inversely proportional, so number of turns should be, so if it is connected earlier, if this tap change is connected to this point, for example, if it is connected to this point, now if you want to maintain this V2, this number of turns should be decreases. So instead of this, now you connect it to the what, from here to here or from here to here, you accordingly connected, so that V2 will be maintained. So V2 increases and it comes to this, maintains the constant voltages. For example, if load is decreasing, means it will become off, so that current is decreases. Now V2 value go on increases more than that 11 kilovolt or whatever requirement is that, more than that it may become 11.2, it may become 11.4. so we have to reduce this voltage. So V2 is increasing, so what I have to do here now? N1 should increase. When you increase N1, V2 decreases and it maintains the constant voltage. So if you connect it here, then if you want is what you do, from here to here you move, or here you move. In this way, you change the number of turns in the primary and maintain the secondary voltages. This is what tap changing transformer works. This is how actually tap changing transformer works. But this works when during on load. During on load also it works, as well as off load also work. On load and off load, two types of tap changing transformers are available. Off load indicates directly that you have to turn off this or switch off this transformer, then you change this tappings. But how many times you are going to turn off and you are going to switch the tappings? It is difficult. So hence basically we don't use this offload tap changing transformer. We use on-load tap changing transformer. That means automatically based on the load as it is changing. So on load only this should go on changes to the number of this different tapping levels. So that is called on-load tap changers. On-load tap changer. So this automatically goes on to this one, or it comes to this one. So that is called on-load. So whenever load is connected and transformer is also on, and during that time only you are changing the tappings from one winding to the one other winding. 1, 2, 3, 4. If you give number, so that during on condition only you can move from 1 to 2, 2 to 3, 2, 3 to 4, or from 4 to 3, 3 to 2, 2 to 1 during on only. And whenever you are doing it, so spark may take place. To avoid that sparking and all those things, the actual connection is different. This is just for the point of understanding the concept. We can draw this diagram, but actually how it works, that is there is some other system is there, that also I will show it to you. But before that, let me know, have you understood this concept, tap changing transformer?
Yes, sir.
Clear? Is this
Yes, sir.
clear?
Yes, sir.
Okay, now what we will do, I will show you that exact diagram. This is the exact diagram of a tap changing transformer, and that too I can write here, on load tap changing transformer. There are two types of tap changing transformers are there, on load tap changing transformer, and another one is off load tap changing transformer. For off load tap changing transformer, you should switch off this supply, then go on changes the tapping. So for example, this is 1, this is 2, this is 3, this is 4, this is 5. 5 tappings we have taken from this main winding, and you can connect this to this different tappings, but that time you have to switch off and you have to do it, and that is called offload tap changing transformer. But practically it is not so sound, or it is not so good, so that the people use this particular on load tap changing transformer. So keeping this on only, so you can change the tappings connected. So that is called on load tap changing transformer, and this only they use it in the practice also. Now consider what all things it consists. A circuit diagram, it consists one step down transformer. Basically primary number of windings are high at the high voltage side, and secondary it is number of turns are less, because it is step down. Down means second level low voltage, and at the primary side voltage will be high. So that is what we call step down transformer. That same step down transformer they have drawn. Then from different number of that portion, for example, this is the 100% winding. From here to here, it is 100% winding, and every 20% they have taken the tappings. In that way you can do it. So this is first, this is 20%, this is 40%, this is 60%, and this is 80%. In that way they have taken the tappings. So around 5 tappings they have taken. So now what happened is different tappings as they have connected here. Now this is the return path. This return path is connected through the help of reactor and to the bypass switch, and this bypass switch is connected to the another reactor, and then it is connected to the this selector switch. This is what the one connection what they have done it. And along with that there are two switches they have used. This is one selector switch, and this one is bypass switch. So this one is a bypass switch, and in between they have used the vacuum switch also they have used. Why these things they have used it, that I will tell you, but this is what the actual work, this is what the actual thing will be there. Now you have seen here concept level, I have shown you very small thing. Sorry. So for concept level, I have shown only the box. The box, what it consists and what all things are there. These are the things which are involved there. Reactors are there. Bypass switch is involved. Vacuum switch is connected, and the selector switch is available. For example, now, if you want to move this selector switch from one number tapping to the second number tapping to this, if you want to move, then how to move? Then that time here bypass switch is there. This bypass switch is connected at the 2 points here, at these 2 points. So when you move this bypass switch down in this direction, if you move, so what happens, this particular point come out of it. So the connection, whatever it is there, this round point, it will come behind that and below that, and this particular point moves somewhere here. So what happens, the connection gets open here. As this connection gets open, this vacuum switch is already closed one, now it becomes open, and that time, same time, what we have to do, this particular point of the selector switch should move to this point. So that I will show you here with some line, another lines. So it moves here. As it moves here, a reactor will be here as it is. This reactor is here. I'm showing it. Then as it is open, now this is open, and now this point is from here to here, this connection, and from this connection to this one, and this connection to this one, and it is here. So during this time, that spark should not takes place. That is what reactor they have connected. This reactor, what it does, which opposes the change in the current, because the voltage difference will be there in these 2 points. The potential difference will be there, and it will circulate the current, and that current produces the spark. To avoid that spark, reactors are connected. Then once if that is over, this vacuum switch will be open. Now afterwards, this bypass switch will be moved in this fashion. Again, when this will be moved in this fashion, so now this again get closes, this reactor part, this part will come to this point, and now you are going to get this reactor and this one, and these things will happen. Again, this is neutral part, and this will get closed. So in this way, you are going to move one point at a time, and that time one will get open and another one will get closed, so that entire circuit will be closed one only, and due to that some current will flow, and due to that current, spark will provide. To avoid that spark, reactor will be used, and next another point will be opened, and that point will be connected, and now entire circuit is connected to what? Second switch, that means second tapping. So this much winding is deducted, so that is not connected in the entire circuit. This is gone now. Similarly, if you want to move, you can move to the third to 2, you can move to the 4, you can move to the 5. So in this way, you go on changing the tappings, and based on that, your voltage at the secondary level changes, because V2 is based on N1. As if you N1 decreases, if you N1 decreases, means if you are moving to the 5, means what? Number of turns you are decreasing. If you are decreasing, means what? V2 is increasing. V2 is increasing means what? Is that go beyond the level? No, we are going to maintain the level. Why we are maintaining the level? Because load is increased, and that voltage was V2 was decreased, and this decreased voltage we are maintaining. We are increasing. That we are increasing with the help of this. If 5 to 4, 5 to 4 to 3, 3 to 2, or 2 to 1, then what happens? This N1 should be increasing. We are increasing the N1. So what happens? V2 will be decreasing. Why V2 will be decreasing? That time load will be less and V2 will be more. And we have to reduce this V2 to maintain the constant voltage. This is how on-load tap changing transformer works. This is how on-load tap changing transformer works. Now in the examination, you can show this diagram. Otherwise, you can show this diagram also, but neatly you have to draw the diagram and you have to explain. This is for just for clearance. I have told you. You can go through the more details also, but this is how it basically works. On load tap changing transformer, and where it is used, why it is used, you came to know, and which type of transformer will be used for that, that also you know. So everything I have covered here from the point of construction, from the point of operation also. This is sufficient for from the point of syllabus. Is there anything to ask? If you can ask, otherwise we'll move to the next point. So if you are silent, then I will also silent. I will sit like this only for another 20 minutes and I will just wind up the things. That's it.
Clear, sir. Understood, sir.
Understood.
At a
Clear, sir.
one time, at one point of time, you cannot understand 100%, but somewhat some things will get clarified. So afterwards, you have to go through that particular point, that portion in the textbook or some other things, and you have to read. Then only some other points you'll get to know. Otherwise, it is not that 100% I have to understand in the particular class only. It is not possible. Okay. So here 27 students are there, and hardly around 3-4 members are replying that understood, clear, okay. But what about others? If you there will be two things. You may understand, you may not understand. That's it. Okay. You will understand or you will not understand, or you might be having doubts. So if you have doubts, you can ask me. Otherwise, at least say that, sir, it's okay. We have understood somewhat, so you can go to the next part.
Understood, sir.
Are you dumb?
Understood, sir.
Understood, sir.
Understood, sir.
So now in this chapter, last part or last concept which I'm going to explain is instrument transformer. Instrument transformer. Instrument transformer. This is the last concept which I am going to cover here. Transformer, you know already. What is instrument? So the transformer which is used in conjunction with measurement instrument, in conjunction with measurement instrument is called instrument transformer. It is called instrument transformer. What is that? What is instrument transformer? It is the transformer which is used in conjunction with the measurement instrument is called instrument transformer. That means this transformer will be used along with the meters, that meters like voltmeters, meters like ammeter, meters like wattmeter. With these meters, if you are using this transformer, then it is called instrument transformer. It is called instrument transformer. Then what is the purpose of this transformer? Measurement of it helps to measure the or measurement of very high voltages, or for the measurement of very high current, very high current, these transformers can be used. Basically, to measure voltage, which meter we use?
Voltmeter.
Voltmeter.
We use voltmeter. To measure current, what we use?
Ammeter.
Ammeter.
Ammeter. Basically, this range of ammeter and voltmeter, practically, if you consider, up to what level you will get. In our case only, in college, we get maximum, we get around up to 1000 voltage range we get. Up to 1000 voltage you can measure. Current, if you consider, in our college case only, if you consider, maximum what level we get? Up to 20 ampere range you will get. Up to 20 ampere range we will get. Now, in case if there is a 5000 voltage is there and I want to measure this voltage. So in between how much voltage will be there, that way I want to measure. So then which one I have to use? Which voltmeter I have to use here? That range of that usually we get up to 1000 volt. And if current is in terms of hundreds to kilo ampere, if it is flowing, then which ammeter I have to use? These ammeter I can use up to maximum 20 ampere. This I can use up to 100 volt. Then these meters cannot be used at this condition. For example, if you consider this is the generating station and there is a step up transformer and there is a transmission line and there is a step down transformer, and in between if you want to measure here current, something like that, voltage, current, something if you want to measure, then here you know already it is in terms of 11 kilovolt to 220 kilovolt, or it may be 440 kilovolt, or else if you consider this one also, it is a 220 kilovolt to 11 kilovolt. Even though it's 11 kilovolt also, it is very high. So this 11 kilovolt also, how I can measure? By using this 1000 volt voltmeter. Or if you want to measure the current at this particular line or in this feeder, then how to measure? By using this ammeter? That is not possible just by using the regular instrument. Then how to measure this? Then I can use this voltmeter only, I can use the same ammeter only, but along with the transformers. The transformer which is used along with this meters is called instrument transformer. This is called instrument transformer. Is it clear why we required instrument transformer?
Yes, sir.
Yes, sir.
Okay. Now here in this instrument transformer, there are basically two types of instrument transformer you will get. Anybody, can you tell me the types of instrument transformer? I guess there is a diploma students also attending the classes. You might have studied at least this type of transformers. The types of instrument transformer.
Current transformer and potential
Very
transformer.
good. So there are two types of transformers are there. One is current transformer and another one is called potential transformer. Another one is called potential transformer. Then what is current transformer and what is potential transformer? As the name itself indicating current transformer, this current transformer is used CT. In short, it is called CT. CT is used with an ammeter, to determine the current flowing in the circuit. That is called current transformer. Current transformer is an instrument transformer. It's a type of instrument transformer which is used with a regular ammeter to check the current flowing in that particular circuit. That is called current transformer. And this is potential transformer, and in short it is called PT, and PT is used with an voltmeter, regular voltmeter, to determine the voltage across the circuit, voltage in the circuit, voltage between the two lines. That is called potential transformer. So basically, now we have to study these both the transformer. Let us see one by one. Very simple instruments are there. One is current transformer. For this current transformer, which type of transformer we have to use? Because basically current is very high, and that current we cannot measure with the normal meters. So that is what we are using the current transformer. So this current transformer basically steps down the current, it steps down the current. The transformer which steps down the current, that transformer which we have to use here. Okay, the transformer which steps down the current, that we have to use it for the measurement purposes. Now basically what we talk step down, step up, it is in terms of voltage we talk, never we talk in terms of current. Okay, so here we have to make the current down. So which type of transformer I have to use here?
Step up.
Yes, very good. We have to use step up transformer. So we have to use step up transformer means here the primary will be having very less number of turns and secondary will be having a very high number of turns, so that voltage will be high. But what about current? Current you are stepping down, and that stepping down current you are connecting to the ammeter, and this ammeter gives the reading. That reading along with the some ratio you have to multiply, and you will get the actual reading, actual value of the current flowing in the circuit. That is what this current transformer does. Current transformer basically inside what will be there? There is basically step up transformer will be there. Are you getting my point? Don't get confused here. It is very simple. Current transformer, that means which uses the step up transformer. For example, I will show you. This is the line. Okay, this is the line, very high voltage line and high current is flowing here. This is the load. Here is the applied voltage. Now I want to measure the current flowing in this circuit, and this current is in terms of hundreds of ampere or it is in terms of kilo ampere. Okay, that much current is flowing. Then how to connect? The connection of this is very simple. The transformer will be connected here. Primary will be connected in this. Okay, this is the primary of the transformer. Then secondary will be here. This is the secondary, and the secondary what they're going to connect is ammeter, and this ammeter is connected here. Now this is the diagram for current transformer. This is the diagram for current transformer. Now primary is here, voltage will be less, low voltage, and current is what? Very high current is flowing. Very high current is flowing here. Then at secondary, voltage will be high, but current whatever it is flowing here, that is very low. Very small current is flowing. So usually this current transformer available with 100/5 ampere, or it is 5000/5 ampere rating, it will be available. That means, for example, if you consider 100/5, that means what? 100/5, that means 20. That is the ratio. So here that 20 is the constant, and if you are using 5 ampere ammeter here, if you are using 5 ampere ammeter, and if ampere is reading 1, if it is reading 1, then what it indicates? 1 into 20. So how much current is flowing here? 20 ampere is flowing. For example, if ammeter is reading 3, because it is 0 to 5 ampere scale, so if it is reading 3, that means 3 into 20. So how much? 60 ampere is flowing. In this way, you are going to measure the high current with the help of a current transformer. And this basically a current transformer is nothing but a step up transformer. Basically, current transformer is nothing but it is a step up transformer. Is it clear?
Yes, sir.
Yes, sir.
In this proportion only you have to do it. Okay, in this proportion, the manufacturer will produce the current transformer in this proportion only. If it is 500 slash 5 ampere, in this way they will give. So in that case, what happens? 500 divided by 5, that means how much? What is the ratio?
100.
It is 100. So this is 100, and ammeter what we are using here, again it is 5 ampere only. If it is reading 2 ampere, if it is reading, that means 2 into 100, that means how much? 200 ampere is flowing in the circuit. That is what the meaning. This is how this current transformer helps to measure the large current in the circuit. Hence, this current transformer always connect in conjunction with the normal instruments or measuring instrument. Hence, it is called instrument transformers. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So
Yes,
now,
sir.
similarly, there is a potential transformer. That is also same thing only. Potential transformer. So when we use potential transformer, when voltage is very high and I cannot measure with regular voltmeter, I cannot measure. So what I have to do? This voltage level I have to decrease first. Then I have connect the voltmeter. Then I can measure the voltage. So in this case, which type of transformer will be used here? In the potential transformer?
Step down.
Step down, sir.
So definitely here step down transformer will be used. In the whenever they call potential transformer, so you should understand that they are using the step down transformer. So this step down transformer, for example, suppose there is a line, 2 lines are there. Okay, and otherwise you can consider earlier diagram only. So this case, and if you want to measure the voltage, so this measure. So this voltage, if you want to measure, if it is in terms of 1000 volt, or if it is more than 1000 volt, 2000 volt, and in between that voltage, whatever it is appearing, we will be not knowing. Then that case, how to measure? Then you can use the this potential transformer, and this potential transformer is nothing but it is a step down transformer. So primary will be connected in this fashion, and this secondary will be lower value, and this lower value will be connected to the voltmeter, and this will be connected. See, this potential transformer will be connected in parallel to the load. Parallel. It will be connected in parallel. And in the current transformer, you have seen how it is connected. It is connected in the series actually. So current transformer will be connected in the series with the line, and this potential transformer will be connected in the parallel. And now this is the applied voltage here. If it is a 2000 volt, then here also same thing, the proportion. So 2000 slash 110 volt, or 2000 slash 220 volt. In this standard rating it will be available. It is standard rating, it will be available. Now based on that, which type of voltmeter or what rating you are using, 100 volt voltmeter you are using, or 50 volt voltmeter you are using, or 200 voltmeter you are using, based on that you have to this ratio whatever you get, that should be multiplied with the scale whatever it is showing, then you will get the actual voltage what here it is appearing. This is what the work of the potential transformer. So potential transformer, the type of step down, the transformer used is step down transformer, which is will be connected in the parallel, and with the help of standard ratio, the standard rating will be there. Based on that, you will get the ratio, and that ratio and this normal voltmeter scale, whatever it shows pointer, that should be multiplied, and you will get the actual voltage available across the 2 point. In this way, we measure the high voltages and high current with the help of two transformer, that is called current transformer and potential transformer. These both the transformers which is used to measure the electrical quantities like voltage and current. Hence, it is called instrument transformer. Hence, it is called instrument transformer. With this, I am going to conclude the chapter which I have started in the morning. It is electrical machine 2. So that I am going to conclude. So it covers all the points almost. Only that precise tap changing transformer is there, that I have not taken because almost similar to this only it works. So that is the homework for you. So go through that, what is precise tap changing transformer, except that everything I have covered except the Scott's connection. That Scott connection I will cover in the tomorrow class, and 100% syllabus will be covered tomorrow of DC and G. So that this electrical machine 2 is also over. Electrical machine 1 notes I have prepared. Tomorrow I will upload in the classroom. Electrical machine 2 notes I cannot give. You have to make your own notes, and 20 marks will be asked on this, both the chapters. You can choose whichever you feel easier and try to get the maximum marks. So with this, I'm concluding the special electrical machine 2 chapter also. So if you have anything, you can ask me. Otherwise, we'll end up the session. Before that, you give the attendance in the chat box, and we can leave the meeting.